we're going to be talking about how to account for test sensitivity now, which is a negative binomial. And this is actually really cool, I reckon. So now let's just have a look. So we've got a number of kind of trials, which is fixed. We've got number of successes, which is fixed, but we think we probably missed some successes because of an imperfect test sensitivity. So what was the sensitivity? Sense equals P, which is like your probability in this instance. So we use a negative binomial. The naming convention for this one is you put the number of successes plus 1, don't ask me why, with P, which is the test sensitivity. Okay, cool. So do you want to pause the video and then fill in these numbers? So we've got 1200 successes, we've got 26, we've got missed success, and our test sensitivity here is 80%, which is 0.8. So again, let's go back to our trusty brute force table. So X, which is the number missed, and then P of X, which is the distribution function of neg bins. All right. So what's the chance that 0 sheep were missed, or 1, or 2, and so on? And let's fill this up to 20, say. Tink. All right, so let's plug in the negative binomial. So let's go neg bin distribution, ting, enter. Alrighty. What was the number of failures? So in this case, the number of missed ones. Ting. Number of successes, that was 26. What was the probability, i.e. the test sensitivity? That's 80% or 0.8. And then we want it to be cumulative. Sweet. Let's fill this up. All right. So looking at this table, the probability, so there was a 99% probability that the number of missed sheep was 14 or less. And let's actually experiment now. Let's put this one as non-cumulative. So let's do the same thing. So neg bin, so number of failures or missed is probably this many. Number of successes was 26. Probability 0.8, and we want false here. And now just while we're here, for interest's sake, note that we don't actually use this number, but we sort of don't need this number because we just need to work out how many were missed. And we don't need to go up to that total one. Anyway, so let's go here. You notice these two will be the same because this is the probability that the number missed was 0 or below, and there's nothing below 0. And this is the probability that the number missed was exactly 0. But then what will happen is you'll notice that it'll go up and then it'll go back down. But if we were to subtract this from this number, we will get the difference here because it adds up. These numbers add up together, which is why this is a cumulative column. Oh, oops, nope. And this is non-cumulative. So let's actually just see how that's graphed, and it might make it look like a bit more sense. So for these, insert, and let's go scatter plot. Look at it. All right. So let's just put this. Actually, let's zoom out a bit, and let's just put this here. So these risks are getting quite small. That's all right. So series, this one here, this is the cumulative risk or probability. So what's the probability that this number here on the x-axis or fewer were missed by the clinical exam? Actually, it might be a bit easier for you to see if I put the axes titles on. This was the probability. This one was this number of sheep missed. And let's just put that over the thing for now so we can have it all on one page. Number of sheep with jaundice missed by clinical exam. Counting for test. Get it away. Sensitivity. And I'll put neg bin. And remember the naming convention. So number of successes is 26 plus 1. Don't ask me why it's plus 1. It just is, apparently. And the sensitivity is 2.8 ping. Make this a bit bigger again. And then I don't like it when it does that. Let's go down to 1. Cool. So this is the absolute number. So this is the probability that exactly 5 sheep will have been missed. So what's that? 13 to 14%. So there's a 14% chance that exactly 5 sheep were missed by the clinical exam who did actually have jaundice. And similarly for kind of this point here, there's a 14% chance, a bit more than 14, that exactly 6 sheep were missed. So this kind of helps us see where the kind of biggest individual probability lies. So if you had to pick one number, you'd probably pick one of these if you like betting. But if you wanted to know the range, so when someone just needs a ballpark figure, for example, do you think 20 sheep have been missed by this test? And you can see, well, the chance that exactly 20 sheep were missed is quite small, less than 0.01%. But it's unlikely to even be close to 20. We're looking at, say, let's have a look at this number here, or refer back to our table. So there's a 99% chance that 14 or fewer sheep were missed by a clinical exam. This is a negative binomial. Any questions? Put them in the box down below.